So question 2, now we'll recognize that this type of graph is, or type of function is in factored form. So the first question we want to ask ourselves, right, is this odd or even? And in this case, we have to count the variables. So as we count them, 1, 2, but again, right, there's actually 2 here. So I need to think of this as x minus 2, x minus 2. Right, there's 2 of those. So we really have, oops, 1, 2, 3, and then a fourth one. So this would be an even function because it has a degree of 4. Now, is this function positive or negative? And again, that comes from our a value. So if we look in front, our number in front here is a -1. So we can say that this is a negative function because a is -1. So how does that determine our sketch? So remember, a -a means the right arrow has to go down. The even aspect of this means that it has to go the same direction. The left one goes the same. So since the right one goes down, the left one will also go down. And how then can we use that to find our end behavior? Well, now that we have kind of a really minimal sketch, we can say as x goes to -infinity, right, to the left, f of x goes, in this case, down. So we're going to say -infinity. And for the right side, as x goes to +infinity, f of x goes, again, down. So -infinity. Okay, so that's it. That's how we have to do that, both in standard form and in factored form. So we have to look for a little bit of different things to get that odd, even aspect of it. But once we kind of get that, the rest of that is pretty easy to kind of map out to get our end behavior. Now, question 3 says for each graph, determine the domain, range, and end behavior. So this is kind of a review of last week. We'll notice we have kind of a crazy looking graph here, right? Lots of twists and turns. So one thing I want to point out since we're here is that our right arrow goes down. So if our right arrow goes down, we know that this graph must be negative. And since the arrows go in opposite directions, we also know that this graph has to be odd. So it doesn't ask us for that, right? But it's just good to know, right? The fact that it's negative because the right one goes down, and it's odd because they go in opposite directions. So it doesn't ask us for it, but it's pretty easy to determine. It might be helpful later. And so now domain, right? Remember, domain is that aspect of where our left and right boundary lines at. Okay, how far left, how far right can we go? Our left edge, if we keep going, it looks like no matter where I go, it's just going to keep crossing it. Even if I put it this way, right, eventually that line's going to go past it. And so we'd say our domain is from -infinity to the left. On the right side, same idea, right? It's crossing, it's crossing, it's crossing, it's still crossing, it's still crossing, and even if I put it over here, eventually somewhere way down here, it will cross. Okay, so we can put +infinity to the right side. In parentheses for both, since those points don't actually exist, right? The -infinity, +infinity. And now range is kind of the same idea, but now going bottom to top. And so if we look at the bottom first, can we set a bottom edge? Doesn't look like it. And it's specifically because of that arrow, right? No matter how far down we put it, that arrow is going to keep going down. So it's going to go all the way down to negative infinity. And where's my top edge going to go? Well, you might think it might be up here because of this particular point, but we have to notice that we still have this arrow here. So even though kind of to the right here, it does kind of top out at that point, there's a whole section of this graph to the left that is going to keep going forever. And so in this case, our upper end, right, our top edge, goes to positive infinity. And end behavior, we could have filled this out from the beginning, but we'll just go in order here. So end behavior, right, as x goes to negative infinity, it's my left. My arrow is pointing up. So since left is going up, we're going to say positive infinity. And as x goes to positive infinity, which is the right, we can see here that it's going down, which would be negative infinity. And that's it. Again, not asking to do a whole lot of stuff here, but we got to make sure that we know what we're seeing. Okay, so again, if you still feel like you're struggling with domain and range, go back and try that Desmos activity, especially a lot of you who didn't do it the first time. Make sure you go back and do that. I think that'll provide a pretty good visual of what's happening. Now, number 4, again, we're asked to do the same situation here. So I'm just going to kind of set it up by writing it all out here. So domain, we've got range. We're going to have positive versus negative. It doesn't ask us specifically, but is it even or odd? We'll go ahead and figure that out. And then what is the end behavior? So domain, okay, if we look at it, the left side, again, by now, hopefully you're starting to see, right, that in a lot of these graphs, there is no edge I can set, because even if I set it over here, eventually it's going to the left, right? It will get there at some point. So our left edge is negative infinity. Same thing to the right. As we move to the right, eventually it will cross. Okay, up top somewhere it will cross. So in this case, we are going to go from negative infinity to positive infinity. And let's go ahead and scoot that over. Whoops. And for the range, same thing, but now going bottom and top. And so this time, though, hopefully you can see there is going to be a bottom edge, right about there. Okay, and in this case, it's not a particularly, nice number. It's not right on that -6 line. So if we zoom in here, I don't know exactly what number that is, but it's between -5 and -6, almost a little closer to -6. So let's just say that that's, I don't know, -5.7. Okay, and if I were to give you the problem like this on a quiz or on a test, right, I wouldn't be picky about the decimal that you pick, right? If it's actually 5.5 and you put 5.6, that's not a big issue, right? It is an issue if you tell me it's -6, because clearly there's a gap there, okay? And it's clearly not -5, okay? But any decimal kind of in the middle there would be fine, okay? It doesn't have to be specific. And since it does actually exist, we do need a bracket. So it does have a bottom edge there at -5.7. This time, if we look at the top, it doesn't really have a top edge because no matter where I set it, in this case, both of these arrows are going to blow past it, right? No matter what. So our top edge really comes out to be positive infinity. Okay, so there's domain and range. Is it positive or negative? Okay, so we look at the right arrow. Our right arrow goes up, which means this must be positive. Is it even or odd? Well, do the arrows go the same direction, or are they in opposite directions? And in this case, they're going the same, so we'd say even. And then how do we write that in terms of end behavior? How do we describe it? As x goes to negative infinity, to the left, f of x goes to, in this case, it's going up. The left arrow is going up, so positive infinity. And as x goes to positive infinity, or the right, f of x also goes to positive infinity, because the right arrow is also going up. Okay, so a lot of information we can just use by looking at the, or gather rather, by just looking at the graph. Okay, so working with factored form, right? One of the reasons why you want to learn factoring is by putting it into factored form, you can pretty easily get an idea of what the graph is going to look like. And this is because those solutions that you find, right, x equals blank, right, x equals 2, x equals -3, whatever, those are the zeros. Okay, we've used that term a little bit, but in reality, when it comes to the graph, they're the x-intercepts, right, where they hit the x-axis. So finding those solutions is really key for us. And what the other thing we need to know is if a factor has an odd exponent, so typically something like x plus 5, okay, or it could be, x plus 5 to the third power, okay, either way. But with an odd exponent, so a 1, a 3, a 5, etc., if it's odd, it's going to cross through that point on the x-axis. If the factor has an even exponent, so typically things like x plus 2 squared, or it could be x plus 2 to the fourth power, any even power, it's going to bounce off of that zero, okay, off of that x-axis.